is I cannot, so I'll put it in red, I cannot say that 1 over n cubed is above or bigger than ln of n over n cubed. The reason being 1 is not bigger than ln of n. Does that make sense? This comparison doesn't work because of that. Okay, so then the comparison is made instead with something that, if I want to show that it converges, it has to be above, and we have to show that that inequality is true. So instead of comparing it to, so ln of n over n cubed, instead of comparing it to something that is, in order for the condition to work, we want it to be underneath. We want it to be underneath the existing function or the function we know about. Okay, so this happens to be this equivalent of 1 over n squared, which we also know converges by p-series. Okay, when we take a look at this comparison, this time it's the bottom is the same. So we're good with that. We need ln of n over n cubed to be underneath. So the question is this true? Okay, is this true? So how we make this comparison after that, if you're trying to determine, okay, is that really truly underneath? Does n really grow faster than ln of n? Kind of picture in your head what ln of n does versus, so think of the graph of y equals ln of x, and then think of the graph of y equals x. Y equals ln of x is really slow growing. Log functions are very slow growing, whereas y equals x actually grows faster. Let's say you don't know. Let's say you don't think initially graphically of it. You guys can always compare functions. So if I want to compare two functions, the relative rates of growth of two functions, and I compare n to ln of n, or vice versa, you guys switch it. It becomes infinity over infinity. They do both go to infinity, but which one grows faster? This is a L'Hopital's idea when we're doing relative rates of growth. So take the derivative, 1. The derivative of ln of n is 1 over n. So if I invert that, I end up with n on top. And then if you let it grow to infinity, your answer to this is infinity. What does infinity mean? Infinity means that whatever was on top of your initial limit actually grows faster. So n is bigger than ln of n. So we can go back and establish that this inequality is in fact true. Okay, so if that's true, and then you know 1 over n squared, the top function is your p-series, you know that that converges, then the bottom or whatever was below it must also converge. It's kind of like, again, the roof collapsing on it, and it forces it to converge. Okay, so DCT is difficult in the sense that you have to figure out which function you have the most information on, and then you have to establish that inequality before you can say that you can make the comparison. So when we initially compared it to 1 over n cubed, even though we knew that one converged, it's kind of like it's in between 1 over n cubed and 1 over n squared. That was the difficult part of that problem. So somewhere in between that, and then it converges for 1 over n squared. We can make that comparison because of that inequality being true. Okay, Min, does that make sense? Okay, any other questions about, so just in looking at these problems, you guys, this section, the 21 through 26, again, are questions that might appear as, you know, like if you guys are given, notice there's no x's in it. It doesn't ask you guys if it's to find the interval of convergence or radius of convergence. It simply asks you, does it converge or diverge? So these typically appear as like 1, Roman numeral 1, Roman numeral 2, and then 3, and then they'll give you guys 3 sets of series, and they might say 1 and 2 converges, 2 and 3 converges. So these are typically multiple choice questions, or they appear within the interval of convergence questions where it ends up being like a endpoint that you guys have to check for conditional convergence or not. Where you compared, there's a few, Sophie. So Sophie's questions, are there any other functions like ln of n where you make a comparison to the p-series? Yes. Yeah, I'll go over 27. Actually, before I answer that question, there are some questions on your College Board, which I can pull up, that have like sine of x and cosine of x in it. And then there is a play on that as well. So we can talk about have you guys all done the College Board questions? the multiple choice at all? The very difficult multiple choice questions. Yeah, and some of those have a comparison to a p-series that has a cosine and sine in it. And it's always playing off of the fact that the maximum of those functions are 1. And so it does impact it in that way. No, I mean, there's certain questions, I think the questions on the AP Central were very theoretical, and some of them, the way that it was phrased was very difficult to sift through what they wanted you guys to answer. So I would say not nearly as difficult as that at all. In fact, I think it's somewhere in between the difficulty of your first quiz and your second quiz. It's somewhere in between that. So I think it's easier than your second quiz, but harder than your first quiz. And then the multiple choice is not nearly as difficult as some of those, because I feel like that one's what was presented on the AP test on AP Central is very theoretical. So yeah, before I jump to the AP Central questions, there's a question on number 27. So notice that this one switches to not actually whether it converges or diverges, but what is the sum of the series? So really, you guys have sum of series like that type of question. There's 3 ways you guys want to look at it. You guys can find the sum of a series if you understand that it's geometric. So number 9, okay, when you're taking a look at number 9, hopefully you guys all looked at that and you thought, how am I getting from one term to the next? Is it geometric or not? And if it was, then you're simply using the error formula for that. If so long as R was between -1 and 1. Then the second type of question where they ask you guys for the sum is like number 10. Number 10, in theory, if I were to add all of these terms together in an infinite series, it's supposed to be equal to or approximate the function itself. So whatever that Maclaurin series is, and in this case it's sine, it looks like it's the Maclaurin series for sine with pi plugged in for x. So if that left-hand side is a sum, then technically, if you were to sum up all of those terms, the sum would be sine of pi. Okay, that's the second way of thinking about it. A Maclaurin series, recognizing it, the function itself is the sum. So sometimes they'll say, what is the sum of that series? You guys have to think, okay, what's the function that approximates it? And then the last one that I can think of that they would ask for is 27 is what type of series? There's only one other series that you guys could possibly find the sum of. Any ideas? Yes, okay, telescoping series. Okay, so for this one, you guys do have to separate the 2 series to figure out it's the sum of 2 fractions. So break it apart and then figure out what A is and what B is. So let's do partial fraction decomposition on this. So as you guys do that, this is all supposed to be equal to the numerator on the left, which is 1. So A, let me just make sure I wrote that correctly, B times 2n minus 3. So as you guys do this, we can let fix my iPad here. Okay, we can let n be equal to 1/2 for us to cancel out the a. So if you guys let n equal to 1/2, the a gets canceled out and you have 1 equals 1/2. You guys get 2 times 1/2, 1 minus 3 is -2. So -2b is equal to, and then solve for b is equal to -1/2. Okay, to do the same thing on the flip side, instead of letting n be equal to 1/2, you guys can let n be equal to 3/2, and that's going to cancel out your b. So when you plug in 3/2 on the other end, you have 3/2 times 2, which is 2a, is equal to 1, so a is equal to 1/2. Take those values, re-plug it back in. You guys have that the series or summation notation here. You guys have a is 1/2 over 2n minus 3, and then minus 1/2 over 2n minus 1. Okay, if you're not too sure what happens to the series itself, plug in a few terms. you basically want to see what cancels out. And I believe there was a bookwork question. I'm thinking of someone who had like a question mark, but then they figured it out. Expand out a few terms. Like, so for example, if you guys were to plug 3 into the first term, you would get 1/6, and then plug 3 into the second term, and you would get -1/10. Okay, so that's me plugging the 3 in. Then try plugging in the 4, and this is just really to verify that it is telescoping. So if I plug 3 in, you guys get 2 times 3 is 6, minus 3 is 3, 1/6, so plus 1/6. Did I do that right? 6. Okay, and then plug in 3 again, you guys get -1/10. What did I miss here? Oh, I didn't plug in the right, I plugged in 3 again. Sorry, guys, I plugged in the same value. Plug in 4 next. So if you guys plug in 4, you get 1/10. And then the next one would be 4, 8, minus 1, 7, 1/14. So -1/14. If you keep expanding it, what you guys would see is the telescoping part. The part that collapses is basically the second term, and then the next term, and then the third term. Fourth term and the fifth term will be the same, but opposite in sign. So they'll collapse or negate each other and cancel out. So you're left with just 1/6, or the first term is your answer. Every single test that you guys have will always, the focus is always on the current chapter. There might be 1 or 2 questions in the multiple choice that is review back to the old concepts, but of course the majority is on series. Anything else from this review assignment? Don't forget, you guys, to memorize your Maclaurin series for this section to manipulate. That's going to be a major focus on the test as well. Okay, another question, the idea that the sum of the series is the function with x plugged in, like number 9 through 11, only works for Maclaurin series. In theory, like a Taylor series not centered at 0, it also works the same way, but they wouldn't expect you to be able to like just look at the coefficients and recognize what Taylor series it is. So it's too complicated. But in theory, it should work the same way, right? But we don't sit there and memorize Taylor series not centered at 0. So it's not expected of you to like just look at a Taylor series and expect to for you to be able to recognize that they're equivalent to each other. Just the conceptual idea behind it, just understand that a function and then that infinite series is, the function is the sum of that infinite series. So usually it's like the Maclaurin series where they would test that understanding. It's too much otherwise. Anything else on this before I move to the multiple choice? I know some of you guys weren't here yesterday, but I was telling I know we went over that really difficult Taylor series question today in class. Your test is nothing like that for response that you guys had in class today. It's a lot along the lines of what you guys saw in your notes, where we did the interval of convergence. You guys had to figure out the endpoints. That part of it is really important. Does anyone have any questions on if you did this section? This is a very important section. Any questions on this section before I move on? And I would say that I would hope that you guys focus on this review as opposed to, oh, and then also the review, if you guys get a chance, the My Open Math is also a good one, because even if you guys don't get it all right, I'm going to go through and then just excuse you guys from it so that it doesn't hurt your grade in any way. But to go through, and it gives you guys, I believe, the answers to it afterwards, like what to compare it to. Oh no, I'm sorry, Tiffany. Yeah, I know that feeling. So I would say focus on that. The AP Central is just good practice. it's actually good for me to see where it is that we need to work on. But your test is like more focused on your notes. Like look at the examples on our notes, look at this review. This review is harder than your test. And then this is also really important. If you guys went over this, I know we didn't get a chance to go over these questions, but do you guys have any questions on this page? And again, this page is more of, does it converge or diverge? Which test are you guys using? Alternating series error bound. I can't remember if there is a question on that on the test or if it's Lagrange error bound, but it's one or the other. The focus is not on error, usually on the test. However, I know AP Central had a lot of questions on that. The alternate series error bound is really just, and it tells you use alternate series error bound on all the AP questions. And you would know that it's whatever is the next term in the sequence that got left off. Okay, so it's the first one that got left off. Yeah, and on AP Central, you see that kind of woven throughout the questions. I didn't assign you guys because I figured it was just too much, but there's a couple of multiple choice on series on AP College Board, and the other one is on Taylor series, but I feel like we kind of like quizzed on Taylor series. We did a lot on Taylor series. You guys should be fine on the test for Taylor series. I would just, remind you guys, go back and look at your Maclaurin series, look at your first two quizzes. Those are important, but there's similar questions on your free responses to those for the Taylor series. And then there's a couple multiple choice on Taylor series as well. None of the multiple choice, just pay attention to that. The one that I gave you guys on AP Central, there was no Taylor series on it because I feel like the Taylor series questions are easier than the testing ones. So I figured, we had done quite a bit on Taylor series and I wanted you guys to get a chance to look at this. So let's actually switch over to College Board and then to Sophie's question about the sine and cosine concept. So number 2, I couldn't figure out how to print it without the answers on it. So when I pull it up, it's going to give you guys the answer to the question, but I figured we can at least work through some of it here. So number 2. Okay, so it says, which of the following series can be used with the comparison test to determine whether the series converges or diverges? So here is the question that Sophie asked, and like, will you guys ever be asked to compare something to a p-series that has sine or cosine in it? So the specific question that she asked, and apparently yes. So we understand that sine and cosine, in fact, sine of x or sine of n in this case, is going to be no more than 1 in terms of the y value. So if this is the case, the maximum value that it's going to attain is 5. So you know that the maximum value of sine is going to be 1. So then let's do what happens if we just picture 1 is there. Then what we're going to compare it to is 4 plus 1 or 5. And the reason being, we can say in a comparison test that this for sure is going to be less than 5 over n squared. And so when we're thinking about what to compare it to, I know that this is going to converge. I need whatever it is that I'm comparing it to be underneath that, so that if my top function and my p-series that I know something about collapses, the bottom one we can also conclude will collapse or converge. Okay, so establishing that inequality again that we were talking about at the beginning. Yeah, so we know for sure that 5 is going to be always bigger or equal to 4 plus sine because of the fact that sine achieves a maximum of 1. Is it picking the max to get it to? It's picking the max to show that this expression you have here is never going to be any more than 5. So if the maximum value for sine is 1, this expression is not going to be any bigger than 5, and at most it's going to be equal to 5. And we need that to be true in order for us to do the DCT test. This function is a p-series that converges, so we have to know that this is above or equal to this. And the reason is that this p-series converges, so what we have to establish is that the other one is underneath that and also converges. And I think there was another one, Sophie, on that with sine or cosine or something like that. So just working through, oh, here's another one, you guys. Which of the following series can be used with the comparison test to determine whether the series 5 plus 2n over n squared converges or diverges? So a very similar question to the other one. And then when you guys end up looking at your answer choices, I know I have the answer here, but when you're looking at this and you're looking at what, like first you're gonna say, okay, what p series am I gonna compare it to? And if you compare the exponents here, you should be looking for something that has like 1 over n in it, right? As the equivalent of 1 over n. So that leaves you really with these two options. Okay, so if you're looking at those two options, you first want to think about if you have the p series 1 over n, it's something that diverges, right? Your information is something that diverges. So that p series has to be underneath the other series that you guys have. And if it diverges, then it's going to push the other one up. That's the conclusion you're making, is that if the p series you have information on diverges, the other original series has to be above that for you to conclude that it also forces it up and it also diverges. So the reason why they picked 2 over n is that if you add 5 to this expression, then you really have something that is bigger on top. You're adding 5 to something that was 2n over n squared or 2 over n. So if you're adding something to it, this is in fact larger than 1 over n. Okay, and this is the one you have information on. This diverges and it's below your original one, so that's going to force the other one to diverge as well. So this is the exact opposite of what we did on top, but is the DCT going in both directions. This one is one in which you have the function you want to show that it forces it to converge, whereas this one, it forces it to diverge. Anything else you guys want to discuss? Again, go ahead, Angelina.
I have a question. I don't know if Angelina was going to speak.
Yeah, Angelina, if you want to, I think I recorded a video on 15 and it's on the agenda. Did you go over the video already? And then someone said, can you go over number 9? Yeah. Okay, you guys, so let's start with 1. And then, okay, so number 1, it gave you guys, this is a series, and they said it's approximated by the partial sum 1 decay. And pay attention to the difference that they, between this expression here and then this expression here. This expression goes on to infinity. When we say that it's approximated by a partial sum where k is a finite value, it means it just cuts off the series at some value k. Okay, but essentially it's the same thing. This side, this is infinite, this is finite. Now the question is, what is the least value k? So if I were to cut it off, in which the alternating series bound error is less than this. So first of all, when you guys see s minus s sub k, that's to say that the infinite series minus whatever, so your actual minus your approximation, or in other words, this is another way of saying error, which is repeated here, is less than or equal to 0.005. And notice that it does say use the alternating series error bound. So it's actually pretty simple, you guys. All you're doing is taking the absolute value of the general term, because that's going to represent your nth term. So absolute value of a sub n. And then you just start, if it's multiple choice, you just start plugging in the values. Okay, so let's say you plug in 6 on, this is a calculator question right here. Okay, you plug in 6 into the absolute value. So if I take the absolute value of this entire expression, all you're doing is plugging into your calculator 6 times 2 to the 6 and seeing if this is less than or equal to 0.005. Okay, it's not going to be equal, or it's not going to be less than or equal to that. So guess what? You move to the next one. You move to 7 and then try it again. Okay, it's not going to be less than or equal to when you guys get to 7 either. But by the time you guys get to 8, so 1/7 to the 7 is also not going to be equal to. So I'll just put or not less than or equal to. So this is not going to work. But by the time you guys get to the 8th one, and don't forget the power of multiple choice. You can do this because you have multiple choice. It doesn't take you guys very long to do. You double check to see if this is less than or equal to, and the exact value is 0.0004882. This is in fact less than or equal to 0.005. Now let's interpret this. When I plug the 8 in, that means that the term, that was the n+1 term. That means that the 7th term got me that error. Okay, so the error is always tied to one more than whatever you guys cut it off at. Okay, and so that's why 7 was the answer, because 8 worked. Okay, because it's always tied to one more than whatever you cut it off at. So that was kind of like a tricky way of asking it. Yeah, the +1 aspect of it, it just throws it off. I think there's a couple of these that were super tricky in that sense. It's always one more. And they always, of course, have to add the deflector question into the mix, right? So you think you get it right. Number 5. Also, so many of these questions were so tricky. So within an AP test, yeah, Tiffany, I hope you feel better soon. Take some Motrin, get some rest. I know, trust me, just knock out and you'll feel a lot better after. Okay, so for number 5, it says, what are all the values of P for which the series -1 to the n+1 over n to the P, which is an alternating P series, will converge? Okay, tricky, because they didn't say whether or not it was absolute or whether or not it was conditional. So technically, if it was absolute convergence that they said, converge here and it says absolutely, then we would automatically say it would have to be greater than 1. But because it was alternating, then we want to consider conditional convergence as well. Okay, so if it's conditional convergence, all P series converge conditionally, even when P is not bigger than 1. So think about if you had -1 to the n+1, 1 over n to the 1/2. Okay, does that satisfy AST? And we know if we've done it enough, we know that it's going to pass AST. The n+1 term is going to be less than the nth term. We know that when we let it go to infinity, it's going to be equal to 0. All P series, no matter what the value of P is going to be conditionally convergent. Okay, and so the answer was P had to be greater than 0 because the values of it being between 0 and 1 also work. So another tricky question. So this one was, it had to be greater than 0. And I think there was another one. Tessa, on page 39, can you go over the difference between 1 and 12? Sure. Was there anything else on the College Board that you guys wanted me to answer questions on? And by the way, Angelina, just a quick, I did record a video on 15, but just a quick comment on number 15 on AP Central. It's very similar to number 1. And since they're talking about partial sums, you kind of want to think about it like just in layman's term, if you contributed, you want to think of a series as like how much is in your bank account so far. So if in January, let's say you look at your bank account, you have 15, and then in February, you check at the end of the month and you have 18, the difference between those two partial sums, the 3 is technically what you added. Okay, think of the difference in the partial sums as the term itself that you would need. So it was the difference between the two partial sums that got you the error. So there is Lucas, for your question about what if it wasn't multiple choice, there's usually additional information besides what is provided there for you to be able to answer it without if it wasn't a multiple choice question, like the alternating series. So for example, on the free response. They might say, what is the alternating series bound if you use a 6-degree polynomial, or if the infinite series was approximated by a 6-degree Taylor polynomial. So you know from that it gets cut off at the 6 degree. So automatically you would jump to one more and plug 7 in. So there has to be additional information for you to determine that. It was multiple choice. With multiple choice, you can work backwards and plug in. Okay. Tessa has a question back on the review. So let me jump back on the review.
Sorry, can you guys hear me? Is it too loud?
No.
Okay, because I'm in the car. So for number 1, I was confused. Okay, so I recognized that one was a p-series and that when I did AST, it was conditionally convergent. But then for number 12, it's the same, it's the same question, except that it's not alternating at the numerator. So I thought you would just go through AST again, and I got conditionally convergent, but it was, it diverges, and I was confused by that.
Okay. Did you hear what you said, Tessa? You said it wasn't alternating, but you did alternating series test on it on 12. Such a common
Oh.
it doesn't have the alternating piece, but I did alternating series tests on it. That is like probably the #1 mistake on testing endpoints as well, is we don't want to, because a lot of the problems, it does result in something that's alternating after we do the plugin for the endpoint. So a lot of people just will default to doing AST and just assuming like check, I'm going to include that endpoint. It's conditionally convergent because I did AST on it. And that is true for this one. You would apply AST to that to determine conditional convergence, but 12, if you look at it, if it's not alternating, you can't apply AST. This is just a comparison test. I would use LCT to 1/n to the 1/2. And because 1/n to the 1/2 diverges, then 12 must diverge. And then discussion ends there. We don't have to discuss AST because it's not alternating at all. Does that make sense?
Yeah, that makes a lot of sense. And it's the same thing for 13 and 14 too, right? Since the numerator is not alternating, it just automatically defaults to diverges by p-series.
Yep. Yeah.
Okay.
So this one, yeah, this one's just a p-series. This one is just a p-series as well.
Thank you.
You're welcome. Are you guys getting better at this, like knowing what to compare 16 to? Like that's just n/n³ or 1/n²? Kathy, any questions? Sandra and Audrey?
I have a question on the same page for number 6. Like when I got to AST and I was doing the second part of AST.
The limit as n goes to infinity?
I think I got confused on that part.
Okay, so it has to be equal to 0, right? So when you're looking at this, I kind of reduce it down to what is the overall exponent on top and bottom. So when I'm looking at this n on the bottom, the highest exponent it has is 1, whereas the top, if you ignore the 2 and you ignore the -1, that's square root of n, or n to the 1/2. So ultimately, when I look at this, I just think of it as there's a bigger n on the bottom. So if you let it go to infinity, a bigger bottom is going to result in a smaller number or close to 0. So that checks out to be true. So anytime you have like a higher power on the bottom and you have a p-series type situation, it does equal to 0.
Oh, okay, because I was thinking like it's infinity on top and bottom too, so I thought, yeah.
If you get stuck there, like if you have infinity on top and bottom, technically it's L'Hopital's rule. And if you were to apply L'Hopital's rule, you should get the same results.
Okay.
On L'Hopital's rule, that it's equal to 0.
Okay, thank you.
And that's because when you take the derivative of the top, you're going to get a -1/2 exponent that's going to bring it down. And then you have nothing on top, or like a constant on top, which is going to result in just the variable at the bottom, which is going to have the variable go out to infinity. So that's equal to 0 on the bottom. So yeah, don't get stuck when you guys have infinity over infinity. Remember, you guys have L'Hopital's rule you guys can apply if it doesn't immediately make sense. But basically, you could boil it down to any p series. It's going to have that. It's going to pass AST. No matter what the exponents are, it will pass AST. It's just a matter of writing out the conditions and check marking it. You guys all understand that factorials, you have to do ratio tests on it. All things with factorials on this page, you should have like immediately thought I'm going to do ratio tests too. Yes, I would default to ratio test. Well, one, if it's not geometric, if you can't rewrite things so that it's to the nth power, default to ratio test. I mean, even if you guys didn't recognize it as geometric, you would do ratio test on it. So yes, if it's a combination of, and I like to describe it as like something that's polynomial. So like number 10, you have something that's like a polynomial, n plus 2n. Those are like polynomials on top and bottom. And then 3 to the n has the n and the exponent. So you've got something exponential mixed in with some things that are polynomial. So I think of that as complicated. And anytime you have something complicated, it's going to be ratio test. So factorials mix into it. You've got exponential, you've got polynomials all mixed in, then it would be ratio test. And I know not all of you guys were here yesterday, but does anyone have any questions on interval of convergence? Testing for endpoints?
Do you mind, I don't have the work for that page, but do you mind doing one of the problems where you can test the endpoints?
Sure. Let me pick one that I think might be useful for you guys. Min has a question. If there is no x in it, I always do nth term test first. That's right. You always do nth term test first. And then ratio if nth term test results in 0. Is that fine? Yeah, that's fine, Min. And then most of the times also one of the LCT tests, if it's a p series, would be something that you would look at. I wanted to do one where I know we did number 4 yesterday, but it didn't result in what I wanted it to for the endpoints, and I wanted to have that discussion. So let me see which one it was.
Sorry, this is a side note. Also, sorry I'm not texting on the private chat. I don't have access to that on my phone. Do you have to, if we were to justify for one of our questions, if we were to say divergent or convergent, whatever, to P series, if we don't say LCT to P series, do we get credit off of that?
You know what? I can't think off of the top of my head. I usually have you guys be really specific, but like, what did the free response say today? It just said P series, right? Did it just say P series, harmonic series? But it wasn't a complicated one. So I have to look back and remind myself. I mean, if they're gonna ding you for it, it might be a point. I'm not sure, but because at most the endpoint analysis is going to be 2 points, so they might dock you down 1 point if you're, because the P series I guess we had today was pretty basic, so technically it is a P series. So what I mean is like if you said just you get down to testing endpoints and you get this one, technically pulling the constant of 1/8 out is not really it's still a P series. But if you start like saying that this is a P series, I would question whether they would give you credit for that unless you mention that you're comparing it to 1 over n squared. Does that make sense? Because it's not like the exact P series, it's a comparison to a P series.
That makes sense. Thank you.
Okay, I'm trying to find one where it was tricky because this is going to happen on your test. Did you guys do 6 okay? We did 4 together. Okay, let's try 60 on there. That seems complicated. Okay, so again, interval convergence, it's a big one on your, and please, if it's on a multiple choice, it's gonna be the longer questions on your multiple choice. If I ask you guys for interval convergence, don't speed through it because you know they're gonna have all the options. They're gonna have the interval, then they'll have the interval with just one endpoint included, then they'll have the interval with both endpoints included, then they'll have the interval with just the right endpoint. So just make sure you guys are thorough in checking your endpoints. So for this one, for number 6, you're applying the ratio test. We know it's the ratio test because this is not geometric. We also know it's the ratio test because we have something that's polynomial and something that is geometric mixed in. So when we apply the ratio test, since it's a complicated fraction, I'm going to have the n plus 1 term first. So as I increment +1, I'm going to make sure that I also, so n plus 1 is the n plus 1 term for that. The absolute value goes around the x, and then you have 2 parentheses n plus 1 minus 1, all over 3 to the n plus 1. I'm going to double back and just recommend again, there was that for one free response that we did the other day, where terms were negative when you evaluated what happens when you plug in 0. So where I stuck the absolute value was only around the x. And that was on purpose because starting at n equals 0, if I were to plug 0 into my terms, only the x is possibly negative. Okay, so then as I increment up, that's the only possibility of it being negative. So that's going to be where I stick the absolute value. If you have things around the x's, like you have x minus 1 here, you're going to want to make sure that you guys have it around the entire expression. The absolute value bars around the entire expression. Okay, so then we times it by the nth term. So that's going to be the reciprocal. So 3 over n, and then n plus 1, absolute value of x, 2n minus 1. Then take the time to simplify your exponents as you guys do this. So this expression becomes 2n plus 2 minus 1, or 2n plus 1. Okay, so now kind of go through and figure out what you guys have left. If I look at this and I look at this, what is the exponent that I have left? What do I have more of? I have more x's on top. So if I subtract 2n plus 1 upwards, what do you guys have left? When you simplify those exponents, what do you guys have left? Yeah. So you guys want to make sure you're keeping track of your exponents, but it's supposed to be 2n plus 1 minus 2n minus a negative 1. So it's supposed to be absolute value of x squared that's on top. And then if you move on to just the threes here and here, there's more threes at the bottom. So you have 3 to the n on the bottom. And then lastly, this aspect with the ends here are a limit question. As you go out to infinity, ratio of the coefficient should be equal to 1. So as you guys gather everything that you guys have left, it should be absolute value of x squared, and I made a mistake here, should be 3 to the first on the bottom here. Okay, over 3 is less than 1. Okay, so you guys still okay so far? With those 3 things, group, reduce the exponents, look at the limit and find out what value you guys have left. Absolute value of x squared is less than 3. Now you guys take the square root. So this is the same step that you guys had on the free response. Okay, you have to take the square root. We had it on 9, so it was nice number before. This time it's absolute value of x has to be between radical 3 and negative radical 3. The distance away from 0 is radical 3 and negative radical 3. Sorry, we dropped the absolute value. Okay, there's your points for setting up the ratio test, coming up with what the results are, having the interval. So those are 3 of the 5 points if we're looking at the same scale as today. And then the other 2 come into play with the testing of the endpoints. So test x equals negative rad 3 first, we're going to plug it back into our original. So n equals 0 to infinity. You've got n plus 1, and then negative square root of x to the 2n minus 1 all over 3 to the nth power. Okay, so then when you guys are simplifying this expression, remember how I recommended that you guys keep, that you guys separate the negative. So it's negative 1 to the nth, or sorry, to the 2n minus 1 power. So distribute the 2n minus 1 power to both the negative 1 and to the square root of 3. So square root of 3 is also, or can be written as 1/2. So when you guys are distributing and doing a power to a power, it's the same thing as multiplying by 2n minus 1, like that, right? A power to a power is multiplying exponents, and then you have 3 to the n. You guys okay so far still? Okay, so was this the one where 0, 1? Can you guys tell me, answer this question for me? I think this is the one that I wanted to talk about. Can you guys plug in 0, then plug in 1, then plug in 2 into that blue negative 1 to the 2n minus 1 part? And can you tell me if you end up with something that is alternating or not before I go further? Is it alternating or not? Min and Tessa, are you sure? Try again, Min and Tessa. Plug in 1, plug in 2, plug in 3. Lucas, that's right.
Wait, I'm sorry. Why do we need to plug in 1, 2, and 3?
Sorry, 0, 1, 2, 3. Plug in the index value into here and tell me whether or not it results in the series being alternating or not. Min, that's right now. Audrey, that's right. Okay, so why, you guys? So if you plug in 0 here, you get negative 1 to the negative 1 power, which is negative 1. If you plug 1 in to here, you guys get negative 1 to the into the first power, which is also negative. If you plug in 2, you get negative 1 cubed, which is negative. So this actually can be crossed off and just applied or simplified to be just negative 1. So please be very careful with that expression. When you guys distribute, depending on the exponent, it has 3 results. It could either always be positive 1, like we saw in today's free response, where you have negative 1 like to the 2n power. That's always going to be positive. So then I cross it off because it's always going to be times 1. It could result in something like this, where it's always negative 1, no matter what value I plug in for n. And then the second part, or the most common one, is that it does result in something alternating. So that totally changes our game plan when that's true, because then now we can't apply AST to it. Okay, so then just writing out and simplifying a little bit further. This was a complicated one. Yet n plus 1, we can drop that out consideration of the negative 1 to the 2n minus 1 power. 3 to the 1/2, if I distribute the 1/2, I get 3 to the n, and then times 3 to the negative 1/2 all over 3 to the n. So I notice the 3 to the n cancels out. Okay, what do you guys do? Oh, and sorry, I forgot to include the times negative 1. So let me rewrite this. You guys have n equals 0 to infinity, -1 times n plus 1, all over square root of 3. What do you guys suggest doing for this series at this point? Like, what type of test would you guys apply here? Any ideas? Good. It's, yeah, you always try the first one. You always try the nth term test first. Take the absolute value of it. You guys end up with infinity as an answer, so that's going to be divergent. At this point, because it's not alternating, we wouldn't go to AST. If we did, it still wouldn't have passed for this one anyway. So at this point, you guys would say you wouldn't include negative square root of 3. Does that make sense to you guys? Maybe I won't do the positive square root of 3 because that one is just a little bit easier, or same thing, actually same results. You guys get the same results. So neither one of them get included because the same thing happens. Okay, so yeah, so that's what I was trying to remember which problem had this, but that might happen on your test. Okay, so just pay attention to the exponent. Make sure you guys plug it in carefully on that one step and make sure to double check to see if it's alternating or not. Was there a follow-up question? So the follow-up question is, we need to simplify first after plugging in X, then test yes. So here's the tip to you guys for endpoint analysis. Do you guys remember? I don't remember which period it was. I messed up on solving for the interval at this point, but then I caught myself before I did this work right here. But you know that you made a mistake on the interval. So let's say I had like set X is between 3 and -3, and then I went on to plug 3 or -3 into here. If you did do that, it's going to result in something that nothing cancels out. So that should be like a big red flag for you. If you see that happens, that means that the interval wasn't correct to begin with. So always expect that something will cancel out. And if it doesn't, then double check, did I simplify it correctly? Did I solve the interval convergence correctly? Because something should simplify out. Your series that you guys are analyzing by n-term tests or AST should be simplified down to something pretty basic like this. Anything else? Okay, number 8, I believe. The free response is a compilation, I believe. I'm trying to remember from what I had last looked at it, is a compilation of a couple of different problems. So I think there's Taylor series on it. There is for sure one of these questions like 1 through 8 on there, where you guys have to find the interval and then test endpoints. So a couple of those things, and then similar to like your quiz, I would say, but of course now you guys have this concept behind it. I would say big picture, make sure you guys know Taylor series, and make sure interval of convergence, radius of convergence, endpoints, those are big picture. And then obviously all the little details with all the different tests, because those get sprinkled throughout. You have to understand that for testing endpoints. I'm sorry, Audrey, you had a question on number 8. Oh yeah, we did do 8 yesterday, but I'm gonna describe that anyways. It's pretty quick to do. Okay, so for 8, you're letting n go to infinity. We see a factorial, so automatically jump to ratio test. And we have n plus 1 factorial. And then absolute value goes around the x, n plus 1, divided by the nth term. So n plus 1 factorial, and then absolute value of x to the nth power. So group things together. This is n plus 2 factorial on top. I would encourage you guys again to expand out factorials if you're not quite used to it yet. But n plus 2 factorial is the same thing as n plus 2 times n plus 1 times n times ... factors go on. And then down at the bottom, you have n plus 1, n, and then n minus 1, dot, dot, dot. So not plus, but times. So when we look at reducing, we can reduce factors. And then after that, the ellipsis is just to say that it continues on forever. But what you're left with is just this n plus 2. Okay, so then we have limit as n goes to infinity of n plus 2. When I simplify the x, I have absolute value of x just on top. This becomes, when you have an n left over with an x, the x becomes basically not very important anymore because it's a limit question. And as you go out to infinity, you're letting this grow to infinity. So your answer is that you get infinity no matter what x is. Go back to your ratio test. The condition was that if you had something greater than 1, it was divergent. But because this is asking you guys to solve for an interval, or like give me some possible values of x that are answers, then we would say that it's not completely divergent. We say it's divergent everywhere except for at the center. So divergent everywhere except x equals 0. I know x equals 0 is the center because there is no shifting that occurs to x. The other flip side of this type of question is if your factorial had been x over x the n over n plus 1 factorial, it would have resulted in you having absolute value of x over n plus 2, and that answer is 0, and that's the complete opposite of this one, where if it's equal to 0, your answer is it converges for all real numbers. And try it out. I know this was an example, but if you look at the Maclaurin series for sine, for cosine, and for e to the x, and you try to do the ratio test to the general term for e to the x, sine of x, or cosine of x, you'll get 0 as an answer because those have factorials in it. So double check that one if you guys want a like example of what it looks like to converge for all real numbers. Audrey, does that make sense? I think that's the last question I see on there. Any other questions? Lucas, you're good?
Yeah, I'm good.
Yes, we did that, Tessa. So did you do partial fraction to it?
Yeah, I did.
Did you end up with something like this for the partial fraction?
Oh, wait, I got -1/2. Okay. I think I see what I got wrong. Wait, hold on. I'll just screenshot it.
Okay. I'm gonna upload the video as well, Tessa, so you can go back and read it. But almost everyone that skipped this question on the homework or put question mark on it, in the comment I just wrote, after you do the partial fraction to it, expand out the series. Like, you know how you were saying, like, what do you mean by plug in stuff? Expand is like, take the 3 and then plug it into both expressions, and then you'll get this. And then plug a 4 in, then plug a 5 in. With a telescoping series, you should see like these terms cancel out, these terms cancel out. So it's like it should pair up, and then basically the only one that doesn't pair up is your first term. And so for telescoping series, is the first term is your answer. You just want to verify that it is telescoping, and to verify it, I would just expand it out a little bit more. Heather, are you good? So my third period has their test tomorrow. So Lucas and Tessa. Kathy, you're in second period, aren't you? Annie, you're in third period?
Yeah, I'm in second.
Okay. So you guys have an extra day. I'll be on tomorrow again at 2:30 if you guys have. Yeah, and you know, series is just one of those chapters I would say the number one thing is if you're not caught up on homework, make sure you guys get caught up on homework. You can't be prepared unless you do enough practice problems with these. Go back and look over the answers on, do the ones, if you want to do some examples that are similar to what is on like your test, do some of the examples on the ratio test in your notes. see if you guys understand how to do that. And then focus less on the multiple choice. The multiple choice is like, it was a stretch. So if you want to go back on the multiple choice and try to understand it, I wouldn't, worry too much about the multiple choice section on the AP Central. Just the packet of notes that you guys have, make sure you go back on Taylor series, because I don't want you guys to miss those questions. Those are easy questions. And I think you guys should be fine. And then, again, interval of convergence, I can't stress enough how important that one is. It's on the multiple choice and it's on the free response. Oh yeah, my open math is good for, it's more like this stuff. It's more like this stuff. So if you feel like you need more practice with is it convergent or divergent, by what test, it's good for that. And it's not that many questions. It should be quick to go through. And if you end up getting a score that's not good, I'll make sure it doesn't affect your grade, because it is optional. How do we know which interval of convergence test? There's only 2 interval of convergence tests. When you're asked that question of finding the interval, there's only 2 things that you're thinking of. It's either geometric series test, which was number 2. And number 2 is the only one that's geometric series, because it's the only one that you can write as all of the base to the nth power. Okay, so for that one, you would just set that between -1 and 1 and solve for x without having to worry about endpoints. Everything else that has, say, a factorial in it, or you can't write it all to the nth power, so you got something that's to the nth power, but something that's not, it's polynomial, it's exponential, it's complicated, then that's ratio test. The ratio test is going to lead you to finding the interval, but after it takes you to getting to the interval part, you have to then plug in the endpoints to determine what series you have. And then when you plug in the endpoints, you might get a series that looks like one of these series, in which case you have to apply either AST if it's alternating, end term test, all of those come into play in the endpoint analysis. And then if you guys come across a question that you want me to go over either on my open math or AP Central, and you want me to just do a quick video on it, let me know. Email me on or send me a message on Remind. Okay, guys, I think you just have to breathe and you'll be okay. The My Open Math is on Canvas, right? Did you guys see it on Canvas? Okay. Did anyone try accessing it? Because I just published it from 2019, and I don't know if it's if you can actually see the problems, but I thought someone said that they could. I think you guys should be able to. I don't think anyone's done it yet. But in any case, let me know if you guys have trouble with it. My Open Math is an assignment on Canvas that's